Hi everyone, welcome to lecture 2 of this module. Today we will learn the object-oriented programming concepts using C++. This is today's agenda. We will start with a brief summary of previous lecture. This will be followed by an introduction to procedural languages. We will see the limitations of procedure-oriented languages and thus the need of object-oriented methodology. We will then have an introduction to object-oriented methodology. Object-oriented programming is a conceptual approach and we will discuss the important features. We will begin with understanding objects and classes in detail. We will discuss how to define a class, provide a class with public and private sections, and provide member functions which work with the class data. In the end, we will also get acquainted to constructors and destructors in C++. These are special member functions for creating and disposing of objects which belongs to a class. So, let's begin with the summary. This is what we saw in previous lecture. This is a brief review. So we saw that C++ merges the concept of object-oriented programming, generic programming with procedural programming. We learned the basics of dynamic memory allocation using new and delete in C++. We saw one sample program and understood the syntax of C++. Then we discussed about the several data types and keywords in C++. The scope of variables is local and global and how they are stored in stack and heap. We had concluded our lecture with an introduction to pointers and how reference variables can be also used in C++. Today, we start our lecture with an introduction to procedural languages. A procedural program is divided into functions, and each function has a clearly defined purpose and a clearly defined interface to the other functions in the program. So this is a structured programming. The program is divided into functions which has a clearly defined purpose and interface to the other functions in the program. But as the programs grow larger and more complex, the structured or procedural programming will show signs of strain. So, let's examine the problems or limitations of procedural languages in detail. We know that in procedural program like C, local data is hidden inside a function and is used exclusively by this function. Whereas global data can be accessed by any function in the program. So the arrangement of local and global variables in a procedural program is something like this. The local variables can be accessed only inside the functions, whereas the global variables can be accessed by any functions in the program. But when we see the same thing in a larger program in this diagram, there are many functions and many global data items. The problem is that this leads to a larger number of potential connections between the function and data. These larger connections not only makes the structure of program difficult to conceptualize, it also makes the program difficult to modify. Any change made in any global data will necessitate rewriting all the functions that access that item. So the larger program, there are larger number of connections and change in any global data may need to change all the functions. The second problem associated with the procedural language is that the arrangement of separate data and functions, separate that is unrelated functions and data, does a poor job of modeling things in the real world. In procedural approach, we'll first concentrate on the procedures we will follow, then think about how to represent the data. But this will not model the real world objects effectively. So we moved on to object oriented methodology. The object oriented approach uses the fundamental idea of into a single unit, combining into a single unit both the data and the functions that operate on that data. That is, the related data and functions are combined into a single entity known as object. You can access that data of an object only using an object's functions, that is, member functions. So, the related data and functions are combined into an object, and the data can be accessed only by the functions in that object. See this diagram. This is an object which consists of data and member functions. If you want to read a data item in an object, you have to call the member function in that object. It will access the data and return value to you. You cannot access the data directly. The data is hidden and safe from accidental alteration. That is how we say that data and its functions are encapsulated into a single entity. Data encapsulation and data hiding are the key terms in description of object-oriented languages. Thus, a C++ program typically consists of a number of objects which communicate with each other, a several number of objects which communicate with each other by calling one another's member functions. These objects communicate with each other by calling one another's member functions. So this is the organization of a C++ program. So we use objects and classes. Let's see what they are. In object-oriented programming C++, you can define many objects of the same class. The class serves as a plan or a blueprint. It defines what data and what function will be included in the object of that class. Defining the class does not create any object, just as the mere existence of data type int doesn't create any variable. A class is a description of number of similar objects. If you see this example, we have a class foobar. So many objects are created of that class, which different functions. A class will have variable declarations and functions only. So a class will have all the declarations of variable and member functions, whereas an object will have the values associated with that. Object will have the values associated with that. If you see this example, human is a class. So all the variables and functions will be defined in that class. Whereas a person Ram, for the matter we have taken Ram, is an object of human class. So the value associated with that is given by Ram. So you can consider a class as a new user defined data type. It's something like a new user defined data type. And when you declare a variable of this data type, that becomes an object. Whenever you declare a variable of this data type, that is an instance of a class, will be an object. Another example, suppose there are many people who are members of rock musician band. There is not one person called rock musician, but specific people with specific names are members of this class which possess certain characteristics. So those people with their names are the objects, whereas the class is rock musician band. So the object is an instance of a class. It's an instance of a class. Now we consider a real life example to understand this concept properly. Suppose we have to design a car. To design a car, we need to know what is a car, what are the characteristics of a car, what all functionalities we can do in a car, and what all happens internally, right? So, first of all, let's see the characteristics. A car will have some color like blue or white, then rear view mirrors, which may be present on driver side only or on the both sides. Then build of interior, which can be of leather, wood, plastic, etc. Like this, there can be many characteristics of a car. So these are all the characteristics of a car. Now let's come to the functionalities. To drive a car, we need to turn on the engine, we need to use accelerator, clutch, brake, gear, etc. So let's see how this can be mapped to a class. We have noted down what are the basic functionalities and what are the basic characteristics. Now we will map this to a class. Our class will be obviously car. Okay. The characteristics of car like color, interior build material, etc., which we saw, which has its own values, are the variables in our class. The value for these components can vary from one car to another. So these are all variables in our class. The value for these components will vary from one car to another. The functionalities of the car which we saw are our functions. The implementation of functions will remain same across cars. You have to turn the engine on, you have to start the engine. So the implementation will remain same, though the output may vary based on the inputs and other variables inside the class. These functions will have the same implementation across all of the classes of car, but the output may vary based on the inputs and other variables. Whatever characteristics or functionalities that we discussed are seen to us from an outside world. So these are all visible from an outside world. So these are categorized as public section of the class. So these variables and these functionalities which are visible from outside world are public section of the class. But there are a lot of things happening inside when we call each of these functions. For example, When we turn on the car, internally the system checks lot of things like engine oil levels, battery health, and other basic stuffs. These things are not initialized directly by the user, but by the turn on function itself. So these internal functionalities, which cannot be accessed directly from the outside world, are categorized under private section. So when we turn on the engine, internally it calls engine on checks or other initial checking programs. So these are not visible to the user. They cannot be accessed directly from the outside world. So these are all under private section. By doing this, we are actually hiding all the complexities from the outside world and exposing only the necessary things. This was something which was impossible in C. Like private functions, there are a lot of private variables also, like the engine model, engine type, engine number, oil level, battery health, etc. So to summarize, we bind together all the variables and functions to represent an entity into a class. We bind together all the variables and functions and represent a class. Also, we categorize the variables and functions into publicly accessible or not based on how relevant it is to the outside world. Now, let's see how a class can be created in C++. So, we have a small program which consists of class small obj, small object. This class small obj consists of one data item and two member functions. So, this is the data item and two member functions. The first member function sets the data item to a value and the second displays the value. The first member function sets the data to a value and the second will display the value. Placing data and functions together into a single entity is a central idea in OOPS concepts called as encapsulation. So in this class, data and functions are placed together. This is the data and this is the functions. Another thing, the class small obj consists of two keywords, private and public. Using private keyword, data is concealed within a class. So it cannot be accessed by functions outside the class even by mistake. Data is concealed in the class by using private keyword. The small obj consists of one data item. Some data, that is the name of the data item is some data of type int. The data items are data members. This data member is followed by the keyword private. So it cannot be accessed from outside world. It can be accessed only from within the class. Then we have member functions which are included within the class. These are the member functions. Set data and show data. They are followed by keyword public. So they can be accessed from outside the class. Now, the class which we have defined is called in this program int main. So the member functions in the small obj class perform the operations of setting and retrieving the data stored in the class. Setting and retrieving the data. In set data, we set the value. In show data, we retrieve the value. So the set data function is accepting a value as a parameter and setting the sum data variable to this value. The show data displays the value. The first statement in this main program, small obj s1 s2. So this is the class. The first statement in the next program, int main, small obj, creates or defines two objects s1 and s2. These are two objects of class small obj. So this declares the class object. Next, we have s1 dot set data. So it is setting the private object through public function. By calling the public function, we are setting the private data. Calling a private member from outside the class will result in compilation error. So s1.setData is used to call a member function which is associated with s1 object. To call a member function associated with s1 object. The dot between s1 and setData. SetData is a member function. S1 is an object. So the member function associated with the object is called, in between we keep a dot. It connects the object name and the member function and executes the member function of the object. The function sets the variable sum data in object S1 to 100. So S1.showData gives the output, the data is 100. Similarly, for S2, that is object S2, the data is set to 200. So it shows the data is 200. So each member function, this show data and set data, are bundled with its parent object and they are setting the integer values. So this is how we declare and define a class and create objects in the main function. This is another example. Here we have a class stock. So class is the keyword which is identifying the definition, that's a class. This is the name of the class stock. So it consists of some private variables and private functions, and this consists of public functions. So if you see here, the private function which we are having here is set underscore total. So we are getting the total value. So the only way to alter the share member of the stock class is to use one of the stock member functions. The public member functions act as a go between the program of object's private members. So the public member functions are an interface between this object and the program. Whereas this function, private function, set underscore total, is not a part of the public interface. It is a member function. It is a member function used by the person writing the class. So the person who is writing the class, he is using this. But it cannot be used by someone writing code which uses the class. Suppose the calculation was lengthy, so this would save some typing and code space. Also, if you have to revise the calculation, you can just revise it in one location. So this is the advantage of using private member function. Now, how the same function in two different objects prints data differently. So in this we have this function show, which is printing the data differently because we are using two objects. So each new object which we create contains storage for its own internal variables, that is the class members. So if this member function, we create two objects. One is Kate.show and one is Joe.show. So this is the object Kate and Joe which are using the member function show. So Kate.shares occupy one chunk of memory and Joe.shares occupies a second chunk of memory. But these Kate.show and Joe.show invoke the same method. They just apply the code to a different data. They will have, each object will have its different variables, so it will print the data differently. Now we come to a very important concept, constructor. If an object can initiate itself when it is created, so where we create an object without initiating itself, without initiating, it gets initiated by itself. It is very convenient. So a constructor is used to initialize the values of an object when it is created. Automatic initialization is carried out using constructor. So a constructor is a member function that is executed automatically whenever an object is created. This prevents uninitialized variables even if the programmer forgets to initialize. Also, we can use define default values to variables using constructors. So constructor is used to initialize the values of an object when it is created. Some properties of a constructor are: a constructor will have the same name as that of class. A constructor has no return value. That is, it is also not declared void. In fact, a constructor has no declared type. Constructors can have parameters to initialize variables inside the object. Inside the object, constructors can have parameters. Also, we can use multiple constructors accepting different parameters. It is called constructor overloading. So, we will see how to use constructors, then it will become clear. If you see this example, we will create a class of objects that might be useful as a general purpose, that is counter. So we have created a class of counter. So counter is a variable which counts things. Assume that counter is important and accessed by many different functions. So we created a class of counter. This example counter is providing a counter variable which can be modified only through its member functions. Sorry, not counter, it consists of count variable which can be accessed only through its member functions. Here, constructor aspects, if you see, they have exactly the same name. In this example, so this is a constructor. Counter colon count 0. The aspect of counter, if you see, of this constructor, they have the same name like we discussed in this. So, the only way the compiler knows that they are constructors is they have the same name as that of the class. Secondly, no return type is used for constructors. This is the second way the compiler knows that they are constructors. So, we have a data type count, then we defined a constructor, initialized it to 0. Then we have two member functions. One is to increment the count and one is to get the count. Now, in the main function, we are printing those count values after calling these functions. So the counter sets to count 0 when an object of counter is first created. So we are using the constructor which is setting the value of count to 0 when an object is created. So if you see in this example, initially C1 is 0. So when we print C1 dot get count, it gives C1 is equal to 0. Also C2 is also 0. Then we have increment count. So C1 is incremented by 1. The variable inside C1 object is incremented by 1. So C1 will become 1 and C2 is incremented 2 times. So it becomes 2. So this is how we can use a constructor to initialize the variables automatically. As you can see, the constructor is executed twice only for C2 and once for C1. So when the statement counter C1, C2 is executed in main, it's executed for once for C1 and once for C2 separately once we initialize. After that, it it causes the counters to display their initial values, which as arranged by the constructor are 0. It then increments C1 once and C2 twice and again causes the counter to display themselves. Now with the same example, we are using a constructor without and with parameter. So we have some parameter. If you see this here, we are using a counter without parameter. Here, a constructor with parameter. The same example. So here, in this case, counter C1 is called. That means C1 is without parameter. So it will be initialized to 0. Then counter C2 is called with some parameter. So it is initialized to 100. So it prints likewise. So what will be the output in this one? First it will print 0. C2 is initialized to 100. Then it is incremented once. That is becomes once 1. And this is incremented 2 times. So it becomes 102. So this is the output when we use a constructor with parameters. Now when you use a constructor to create an object, the program undertakes the responsibility of tracking that object until it expires. The destructor should clean up any debris so it actually serves a useful purpose. For example, if your constructor is using new to allocate the memory, the destructor should be used with delete to free that memory. Correct? So like a constructor, destructor is also formed from a class name. It is preceded by a tilde. Also, like a constructor, a destructor can have no return value and has no declared type. Unlike a constructor, a destructor must have no arguments. A destructor cannot have any arguments. So just as a program invokes a constructor when an object is created, it invokes a destructor when an object is destroyed. You can have only one destructor per class. It has no return type, no arguments. Its name is class name preceded by a tilde. So, if you see this example, you have a class and then one private data member and public function. So here the constructor is created, here it is destructed. So you should use this to destruct or free the memory which is used. So the summary is private data or functions can only be accessed from within the class. Public data or functions are accessible from outside the class. Then the structure of a program. This is the keyword class. Foo is the name of a class. We have keyword private, then private data, then keyword public, then public functions and data. These are all inside braces of class. This is similar to a structure. Thank you.